This is video 3.1. In it, we'll perform the mathematical exercise of decomposing vectors. The question. A rocket is launched with an initial velocity of 200 meters per second at an angle of 65 degrees above the horizontal. We'd like to know, what are the initial horizontal and vertical components of the rocket's velocity? Step 1 is to draw a diagram with the information that we know. In this case, we know that the initial magnitude of the rocket's velocity is 200 meters per second, which we've drawn as the hypotenuse of the triangle, and that the angle as measured with respect to the horizontal is 65 degrees. First, we'll find the horizontal component. Now, if you don't know the helpful mnemonic SOHCAHTOA already, it would be useful for you to learn it now. It's a mnemonic for remembering the forms of the trigonometric functions. Reading it out, it says that sine of the angle is equal to the opposite over the hypotenuse, cosine is equal to the adjacent over the hypotenuse, and tangent is equal to the opposite over the adjacent. And when they say opposite here, they mean the side opposite to the angle. So, with the angle in the bottom left-hand corner of the triangle, the vertical component is opposite and the horizontal component is adjacent. Because we're looking for the horizontal component, we use cosine, because we know the hypotenuse, we know the angle, and we're looking for the adjacent component. Now the cosine of the angle is equal to the adjacent over the hypotenuse, and if you multiply both sides by the hypotenuse, you get that the adjacent part of the triangle is equal to the magnitude of the hypotenuse times the cosine of the angle. If we plug that into our calculator, we get a number with many digits, but we only know the angle to 3 significant figures, so our final answer can contain no more than this, and is 84.5 meters per second. Step 3 is to find the vertical component. Because the vertical component is opposite of the angle, and we know the hypotenuse, SOHCAHTOA implies that we use sine. Rearranging the equation, we get that the vertical component is equal to the hypotenuse times the sine of the angle. Once again, this gives us too many significant figures, so we round it off and we get 181 meters per second for the vertical component of the rocket's velocity. That concludes video 3.1. Check out PhysicsX on the app stores. This revolutionary physics app for smartphones and tablets contains over 100 videos and 500 multiple choice questions designed by education experts. It's been proven to improve scores for intro college physics, AP physics, MCAT physics, and more. Just look for the blue icon.